Welcome back. In this session, we'll continue with the discussion on realization of discrete type systems. Alright, so let's start. So we know a discrete time system is given by the difference equation, and for a difference equation that is given by something like this. K1 of n minus k is equal to summation k running from 0 to m bk x of n minus k. Now what we'll assume? We'll assume that this part is 0. So we'll assume this part is 0. So we'll have k is equal to 0 to m b of k x of n minus k. Now we'll denote this by a special name later on, and this is called FIR system. That we'll see later. This is referred as FIR system actually, or FIR filter more commonly. This is referred as IR filter or IR system. That we shall see later. Alright, that will do that. But how do we realize this? You can also write this as in the transfer function file. So we can take the z transform on both sides and say this is y of z, this is y of z is equal to summation k from 0 to n bk x of z 0 square minus 2. Alright, now taking x of z common and dividing y of z by x of z, get summation k from 0 to n bk 0 square minus 2. There are no poles in this system, you can check. There are only zeros, right? So this is the transfer function of this system, where this part is 0. Now we named this system earlier. We call it this is mean averaging system. This is a mean averaging system. Why mean? Because this is the sum of all the present and past values of input. We just move over the present and past values of input. And this is not a recursive system. This is not a recursive system, right? So let's realize this. So let me expand it. So y of n is equal to b naught x of n plus b1 x of n minus 1 plus b2 x of n minus 2 plus so on up to bn x of n minus. So this is very easy to realize. So if I have input x of n, this is the input x of n, then we'll pass this through a delay element, right? So we'll pass through this delay element like this. Then we'll have here x of n minus 1. Alright, then we'll again pass this through a delay element to get x of n minus 2. So again pass it through this. Then here we have x of n minus 2, and this will continue up to this mth order delay element, and this will be, so what will be the last one? It will be x of n minus m. Alright, so this now these are available to us. What we can do, we can pass these through the multipliers. So what we'll do, we will pass these through multipliers. So the multiplying value is b naught. Here what we'll do, we will pass this through a multiplier with multiplying value b1. Here we'll pass this through a multiplier with multiplying value b2. So what we have here it is b naught x of n. Here it is b1 x of n minus 1. Here it is b2 x of n minus 2. So on, and here we have bn x n minus n. Alright, and what we'll do, we will add first to this and this. So first we'll use a summer here. then add these two. Then we'll add these with this. So we'll add one more summer here, apply this to this. So this will give us the three term. Then we'll continue this procedure. So we'll continue this procedure. Right. This will continue, and we'll have. I don't know what will be the value of this. Obviously, it will be of -1. We'll add this, and finally we'll add this to this. So we'll add this to this, and this is our y of n. So this is our y of, right? So this is our final y. Right? Have a look at this. These are actually called tappers. These, when you pass this, take a sequence or a signal from, and when speak a signal from somewhere, this is the first tapping of the signal. These are tappers. These are the first tappers. And this is how we realize the system where the past outputs are 0. This is how we realize that system. All right. Okay, please follow the example. Please do this example yourself. If y of n is twice x of n plus 5 x of n minus 2 plus 7 x of n minus 3 plus 10 x of n minus 8. All right. Try to realize this system. All right. Let me end this session here. Let me show you the example also. Okay. Let me show you the example before I end. Let me continue with the examples so that you will be able. All right. Let's suppose y of n is 5x of n plus 3x of n minus 2 plus 4x of n minus 3. Let me use this. Okay. So first what I will do, I'll first have x of n. Then I need x of n minus 2. So what we'll do, we'll pass this twice through a delay element. That will give us x. So this is delayed. This is delayed. So this one will be x of n minus 1. This one will be x of n minus 2. Then what we'll do, we'll again pass through a delay element. And this one is x of n minus 3. All right. So then we'll tap these. So this is called tapping. And the value of this multiplier is 5. And again, we'll tap this. And the value of the this we don't require this one because this is not needed there. And the multiplying value is 3. And finally, we have this, and the multiplier value is 4. All right, so what we have here, we have 5x of n, 3x of n minus 2, and here we have 4x. Here we have 4x of n minus 3. So what we'll do, try to add these. So we'll bring it here and add this. So we'll add this with this, right? So we have got this part and this part. Then we'll add it. All right, so this is y. Now try to realize this part yourself. Right? See, what's the important point here? You don't have x of n minus 1 connected here, right? But you have a delay element. You don't have x of n minus 1 connected here. But you need x of n minus 2. That's why you need to pass it twice to the delay element. Although you obtain x of n minus 1, but this is not required. All right, so let me end it here.